Hi guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Jest, TIFR, IIT-Jam exam, and other exams related to physical science. And my courses are absolutely free of charges. Anyone can watch and enjoy my lecture and crack the exams related to physical science. And also, I would like to thank you, the people who have subscribed my channel. And I would like to request the people who haven't subscribed my channel yet, please subscribe my channel and enjoy my lectures. And it is the lecture number 7 of quantum mechanics. I'm going to start. Okay. So, so now we are going to, so in previous lecture, we have studied the commutator algebra and their property, and we have solved questions related to those properties of commutator algebra. Okay. So now we are going to study Hermitian operator and wave function. Okay. So I'm going to start. So we'll start with Hermitian operator. Okay. Hermitian operator. Okay. So Hermitian operator, an operator A is an operator A cap is said to be said to be Hermitian operator. Hermitian if A dagger equal to A cap, right? A cap dagger, right? And or we can write like in this term psi A psi A cap phi. This is going to be phi A cap phi A cap psi. It's complex conjugate. Okay, like this. You can write like this as well. Okay, so an operator is said to be Hermitian if A dagger equal to A or this, right? If it's anti-Hermitian, then what is going to happen? Anti-Hermitian, anti-Hermitian, A dagger is going to be A. I'm not writing cap, so it is operator and it is understood. Okay, so A dagger is going to be A, or we can write psi A cap phi. Okay, this is going to be minus psi A cap psi star. Okay, this is the one as well. And now we can write next one is, and you need also, this is the Hermitian operator and this is anti-Hermitian operator. And in Hermitian operator you can also write in Hermitian operator roots. Okay, the eigenvalues of Hermitian, the eigenvalues of Hermitian Hermitian operator Hermitian operators are real. Okay, Hermitian operators are real. Eigenvalues of Hermitian operators are real, and this one, and the eigenvectors corresponding to different eigenvalues are orthogonal. Okay, for Hermitian, it is for Hermitian. The the eigenvectors, eigenvectors of Hermitian, eigenvectors of Hermitian operator Hermitian operators corresponding to different corresponding corresponding to different eigenvalues are orthogonal. Okay, orthogonal. Okay, the eigenvectors of Hermitian operators corresponding to different eigenvalues are orthogonal. Okay, so this is this is the property of Hermitian operator. Okay, and also the condition for anti-Hermitian I have explained. Okay, so now I'll tell you how to check when the operator is Hermitian or not. Very important in question. Okay, how to check whether an operator is Hermitian, and whether an operator whether an operator is Hermitian. Okay, how to check whether an operator is Hermitian. Okay, how to check, this is important. So this is for for Hermitian operator. Suppose for Hermitian operator, the value of psi a psi, okay, psi is wave function, value of Hermitian operator, that should be equal to a psi psi. Okay, a psi psi for Hermitian. Okay, if this is the case, okay, if this is the case, if this the operator the the product of psi a psi is equal to a psi psi, then this is Hermitian. If it is not, in if the value is this, second point, if psi a psi, this product, okay, the expectation value of a, you can say that operator is minus operator a psi psi. If this is the case, then this is anti-Hermitian. Okay, anti-Hermitian, very important question. And anti-Hermitian. So this is, if okay, so we have to check whether this is Hermitian or not. We'll use this condition and solve it. If we get this equal to this, right, then this is Hermitian. If the value of this is minus this, then it is going to be anti-Hermitian. Now I'm going to solve one question, then it is going to be, it is, you need to check. So how we are going to check it? The same. So we know the property which I have already mentioned now, right? So we know this psi, this is an operator, so psi dx upon psi, this we'll find out. So we can write this like this, uh, integration psi del over del x psi, this is psi star, okay, it will become psi star dx. Okay, we'll find out this one. Okay, and we have taken this normalized weight function. Okay, this one. So we'll solve it. So this is going, so we'll use integration by part. So this is first function, integration of second, d psi over dx minus integration differentiation of first function, that is psi star. Okay, integration of second function dx, and this value is going to be x, right? We have used integration by parts, right? So now we know the value of psi, okay, is 0, that tends to 0 at infinity, at minus infinity and plus infinity. This is minus infinity to plus infinity. Okay, minus infinity, limit is minus infinity to plus infinity, minus infinity to plus infinity. Okay, okay, so this, it means this value integration minus infinity to plus infinity d psi over dx into dx, this value is going to be 0, because psi is 0, tends to 0, or psi is 0 at plus minus infinity. Okay, psi is 0 at plus minus infinity. Okay, this we should know. So this value is going to be, now I'll write in next page. So this value is going to be psi del over del x psi. Okay, this value is going to be, this value is 0. Okay, so it is going to be minus integration, this one. Okay, this, so this is del psi over del psi star over del x. Okay, and this one, guys, this is integration differentiation psi x, right? We know the integration and differentiation will consider got cancelled, and this we know integration and differentiation is there. So integration del psi over del x dx, right? So it is going to be this integration, right? So this value is going to give 1. Okay, how we can say that, though we can say this integration and this differentiation. Okay, so this is integration, this is differentiation, this value is 1, and this is going to be psi, that value, this value is going to be psi. Okay, let me just check my internet working fine. Okay, is better. Okay, so this is value is going to be psi, right? So this is going to be psi dx. Okay, you consider it, right? This is integration, this is differentiation, this is 1 psi, right? This value is psi. Okay, so this is the 1, So we can write this like minus integration psi star. Okay. We can write minus integration del over del x psi star psi dx, right? So we can write in this form. So this is going to be minus del over del x psi minus del over del x. This is going to be psi, right? We can write this, or we can write minus del over del x psi. This is the condition, right? I've already explained this one, Hermitian, right? If this value is like this is Hermitian. If this is minus a psi is a psi, this is Hermitian. If psi, this is minus a psi, this is anti-Hermitian, right? So here we can say this is the operator psi, minus sign is there, right? It means that implies anti-Hermitian, anti-Hermitian, anti-Hermitian. Okay. So, uh, so the operator del upon del x is anti-Hermitian operator. So you understood, right? This is very important for Hermitian. We can write if operator is an Hermitian operator, okay, then the operators must satisfy this property. If it is anti-Hermitian, then operator must satisfy this this condition, right? So we have used here. We have what we have done is this is the operator, and we try to find the value of this, and we solve it, and finally we got this value, right? And this is the property of anti-Hermitian. It means this del over del x is anti-Hermitian operator. I hope guys you understood it. Okay, so this is about anti-Hermitian and Hermitian. So if any operator is given and you need to find it is Hermitian or anti-Hermitian, you can easily find out using these two properties which I have explained. Okay. Next we are studying wave function. Okay. In next lecture we are going to study postulates of quantum mechanics, right? So that is going to be very interesting. Okay. So yeah, this is wave function. We are going to study now. Wave function psi. Okay. This we are going to study. Okay. I'll write the point for it. There is no physical significance. There is no physical significance. There is no physical significance of the wave function function. Okay. Okay. So for wave function there is no physical significance, but with the help of, or we can write, we can get all the information about the system. We can we can get all the information. We can get all the information about the system, okay, quantum mechanical system. Okay. with the help of with the help of wave function wave function wave function psi. Okay, so with the help of wave function psi we can get all the information about the system. Okay, psi which is function of x and t. X and t. Okay, okay, so here we'll write psi which is function of x and t mod square. Okay, this we can write psi star psi mod square. Okay, so this is the meaning of this is the probability. So this gives the probability of probability probability of probability of finding the particle 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 at position x at position x. Okay, so mod psi t mod square psi t is probability of finding particle, okay, at position x. So this is one. So now we'll write probability of finding particle, okay, in 1D. So in 1D, so this is going to be probability of finding particle, that is p is going to be it is going to be integration psi xt, psi is function of xt mod square dx. Okay, in whole range. Okay, property in this space probability of finding particle in 1D is this mod of psi xt whole square dx. Okay, and unit of wave function is unit of wave function. What will be the unit of wave function? Unit of wave function for 1D is going to be 1 upon root L. Okay, this is the unit. In 2D the probability of finding particle is going to be integration in 2D, that is psi is function of xt mod square of psi xt ds. Okay, ds, and the unit of wave function is going to be 1 upon L. This is 1 upon root L. 1 upon root L. Okay, in 3D probability of finding particle is going to be psi which is function of mod squares of psi whole square, mod square of psi d tau. This is volume, right? And the unit of wave function is going to be 1 upon L to the power 3 by 2. Okay, in n dimension unit is going to be unit of wave function, unit of wave function is going to be 1 upon L to the power n by 2. Okay, 1 upon L to the power n by 2. That is in n dimension. Okay, so this is the probability of finding particle. Okay, in all space. Okay, in 1D, it is in 1D, it is in 2D, it is in 3D. Important one. Okay, so the condition for psi being wave function. Okay, what are the conditions that psi must satisfy for being wave function? Okay, that I'm going to write now. So I'll write it. So the first one is, I'll write by number. Okay, the first one is psi should be, the condition for psi to be wave function. I'll write it. Condition for psi to be wave function. Okay, the condition for wave function. Okay, any function is given, so we need to find condition. I'm just directly writing the condition. So the number one, that is psi. If we say psi is wave function, it means psi must be single valued. Okay, psi should be single valued. Psi should be single valued. Condition 2, psi should be finite. Okay, it should be finite. It should be finite. Okay, third condition, psi should be continuous, and del psi over del x also should be continuous. Okay, the differentiation also should be continuous. Okay, fourth is psi equal to 0. Psi should be 0 at plus minus infinity. Okay, at plus minus infinity, value of psi should be 0. Okay, psi. Okay, now fifth condition, very important. Psi should be that it should be square integrable. Okay, square integrable. I'll solve example, then it will be more clearer to you. Okay, square integrable. Okay, square integrable. Square integrable. Okay, it should be square integrable, and okay, and the sixth is the integration of psi xt. Okay, that is mod square of psi xt. The integration should be this dx must be finite. Okay, should be finite. Okay, if psi satisfy these properties, these six properties, then we can say that psi is the wave function. Okay, if any one of this is not satisfied by psi, then that psi is not wave function. Okay, yeah, so this is the one. This is minus infinity to plus infinity. Okay, so these are the condition for any function psi to be wave function. Okay, now I'll solve some questions and then it will be clearer. Okay, let me just check, is YouTube working? Okay, it's working. Okay, next. So question I'm writing. Question number 2 for this lecture, and that is, we have been given psi is sine a sine x, a sine x. Okay, this is given. Okay, and we know the graph of sine, right? This one the graph. Okay, this one is the graph. Okay, we have been given psi equal to a sine x. Okay, and we need to find whether this is wave function or not. Okay, okay, so find so we need to find it, whether it is wave function or not. Okay, wave function or not, that we need to find. Okay, okay, that we need to find. So I'm writing it now. So we'll check first condition, right? Obviously, the first condition is it is single valued. So we can put any value of x, it will give only one value, that is single valued. Okay, so it is single valued. Single valued. For example, if this is this, for this value will be single, right? We can't get this value here, right? So this is single value because for any value of x, whatever value we are going to take, this is giving single value, and it is sin x, right? The sin x value of sin x is between -1 to +1. Okay, so it's a single value. First condition is satisfied. Single valued. Now second condition, this is finite. Okay, this is finite. Okay, finite at, this should be finite, right? This is finite at -1, between 1 to -1 to +1. This value is going to give finite value, right? So second condition satisfies. Second is finite. Okay, so this will give finite value because value of sine is between -1 to +1. Which condition third we are going to check? Okay, so value, we can see psi is not equal to 0 at x equal to ±infinity. Okay, so the condition we can see here, right? Yeah, psi must this one, psi is 0 at, psi must be 0 at infinity, ±infinity, right? But it is not giving 0. Psi is not equal to 0 at ±infinity. Okay, so this is not the wave function from here, but we'll check all the property. Okay, number third, so we can see it is continuous. Okay, because if it so sin x is continuous, so we can see the graph. Okay, so psi is continuous because sin x is continuous, psi is continuous. This property is also satisfied, and del psi over del x, that is here we can check. So I'm telling all the properties, right? Because so that your all doubts will get clear. Okay, I'm explaining all the property using this question. for making your all doubts clear. Okay, so this is psi, and we can say del psi over del psi over del x. This is differentiation of sin x is going to be cos x, right? Cos x, that is also continuous. We'll check which are the conditions which are not satisfying. Okay, so this is continuous, because cos x graph is like this, so this is also continuous, which will start from here. Okay, so this is also continuous. Okay, next point is we need to check this square differentiable, right? This one, size, this should be finite. Size, this is not satisfied, this is satisfied, this is satisfied, this is satisfied. Integrable, square integrability will check. Okay, next, this is third, this is 4 actually. Yeah, this is 4, this is 4. Now fifth one we are going to check square integrable, right? Square integrable means square of wave function psi. Okay, so that is, because value of psi is this one, huh? This one. Okay, a sin x. So square integrable, so this is a sin x square. This should be integrable. Okay, this should be integrable. Let's see whether it is integrable or not. Okay, we are going to check. So we'll solve it, right? It is going to be mod a square, will take outside, and this is going to be sin square x dx. Okay, and this is minus infinity to plus infinity, minus infinity to plus infinity. So psi must be square integrable. Okay, wave function must be square integral. So we'll solve it. So this is going to be mod a square, and we'll change it, right? Minus infinity to plus infinity. This is going to be 1 minus cos 2x. We'll use the property of cos 2x. Okay, 1 minus cos 2x by 2. Okay, dx. Now this is going to be mod a square. This is 1 by 2 x minus 1 upon 4 sin 2x minus infinity to plus infinity. We have integrated, right? And this value tends to infinity. Okay, yeah, this value tends to infinity, means it is not square integrable. Okay, so it is not psi is not square integrable. So this condition, fifth condition, is also not satisfied. Okay, and so this means sixth condition is satisfied, because this value gives the finite value, right? This integration. No, this is the square integrable. Okay, this is not satisfied, right? Square integrable. Okay, square integral, and this is not satisfied, right? This is giving a value infinity. That means this implies psi equal to a sin x is not wave function. Okay, okay, so this is this is the value of this minus integration minus infinity plus infinity. This is sixth property, right? Actually, this is the sixth property. This one. This is not giving a finite value, right? And it is so that's why we can say psi equal to a sin x is not wave function. Okay, so this is not a wave function. We'll check next now. Okay, and or we can write psi cannot be this, psi equal to this cannot be wave function or is not wave function. Next question we're going to write. So next question is this one. Question number third, we have to check psi equal to plus minus root 3x. Okay, so we need to find whether it is wave function or not. It's clearly saying it is not wave function. Why? It is not wave function because it's not single value. Okay, for any value of x, for any value of x, for any value of x, right, it is going to, psi is going to give two values because psi equal to plus minus root 3x, right? So it's not wave function because because it is double value, double valued, double valued function. Okay, okay, so it's not it is not wave function because it's double valued. Okay, because it's clear, right? For suppose we take value of x equal to 1, it is going to give the value of psi r 2, that is minus root 3 and plus root 3, right? So it is not single value, so it's not satisfying first condition. It means it's not. So any any wave any function being a for any function to be a wave function, that function must satisfy these six properties. If it satisfied these six properties, then we can say that function is wave function. Okay, so it is not wave function because it is double valued function. Okay, so psi value or psi is double. Okay, so it is double valued function, so it's not wave function. So very easy, right? Now question number 4. Question number 4 is before, okay, question number 4, right, this one. uh, Question number 4 is, we have been given value of psi equal to 2 minus mod x. Okay, 2 minus mod x. We'll check this now. 2 minus mod x. So this is, yeah, first condition is satisfied. This is single value. For any value, single valued. Okay, single valued. Because for any value of x, right, it will give only one value. Okay, this is mod x. Suppose we take 1, so x value of x is where, if we suppose take, if we take 1, okay, so it is the value of psi is 1, right? It's a single value. First condition is satisfied. Now we'll check second condition, that is finity, right? We'll check it whether it's finite or not. Yeah, this is finite. This value is finite. Okay, but now we'll check condition number third. This is, that is fourth one. This would be third, fourth. Okay, so we'll check this one, fourth condition. Okay, third one is, this order is right. It should be third and it should be fourth. It's okay. We'll check this one. Okay, so we can see the value of psi not equal to 0 at x equal to plus minus infinity. So if we take x equal to plus minus infinity, it is not going to give 0 value, right? So it is not satisfying according to this fourth condition, right? So it means not a wave function, not wave function. Very simple, guys. Very simple question. Okay, not a wave function. Well, now next question. Anything remaining? Okay, yeah, it is differentiable. Okay, this is differentiable. Yeah. Okay. but it is not satisfying this condition, right? Other condition is satisfying but not this one, so that's why it's not wave function. Next question. Question number 4. Question number 2. Okay. Okay. Question number 4 is, this is this one. Psi equal to, we have been given e to the power minus lambda x. Okay. We have to check. Okay. First condition is satisfied. This, it is single valued. For any value of x, it is going to give single value. Single value. Okay. Second condition, yeah, it is finite. It will give finite value. Okay. For value of x, it is going to give finite value. Third condition, this one, value of psi, not value of psi not equal to 0 at x equal to infinity. Okay, though the value of psi is 0 at x equal to minus infinity. Okay, but psi is not equal to 0 at x equal to plus infinity. It means it is not the wave function. So psi equal to e to the power minus lambda x, not the wave function. Okay, wave function. Okay, now we can make this wave function putting some condition. How? Like we can write psi equal to uh, e to the power minus lambda x when x greater equal to 0. Okay, x greater equal to 0, any value of x greater equal to 0, or 0 when, okay, at okay, or 0 when x less equal to 0. In that, if we put this condition, we can make it a wave function. How? So now we can see for x equal to, because if x less equal to 0, right, it is going to give value 0, right? So for now we can see, for x equal to infinity, we can check at x equal to 0, the value of psi is going to be e to the power minus infinity, right? And that is equal to 0, thanks to 0, right? So this means it is going to give value 0 at x equal to plus infinity. Yeah, at plus infinity it is going to give 0, and at minus infinity it is already 0 according to this condition, right? So now this is this is satisfying this condition. It means, and other conditions are already satisfied. The other condition also, it is satisfying other condition as well. Remaining conditions for psi to be wave function, it is square integrable, and it is giving the value of integration of minus infinity to plus infinity, psi mod square of psi dx is going to give a finite value, right? So all the condition it is satisfying. It means psi is wave function. Wave function. Okay. Next is question number 4. This is psi equal to a e to the power minus x minus alpha x square. Alpha is constant. Okay, we need to, it's single valued. Okay, first condition satisfied, single valued, and this is the first condition. Second, that it will give finite value, and we can see this is x square. Okay, guys. So it means the value of psi is going to be 0 at x equal to plus minus infinity. Okay. Fourth condition, we can see psi is continuous. It is also and differentiable. Okay. And this and differentiation of this differential. Okay. d psi over dx is continuous. Okay. We can write differentiable. Okay. Continuous. Psi is continuous and differentiable. Right here we have written this property. Okay. This is continuous and differentiable. Okay, so this is we can see it's we can see that it's differential continuous. Okay, and also it is square integrable. Square integrable. Okay, and option 6 that this is, and if we find this value, we can see minus infinity plus infinity psi mod square dx. We can see this is value of x, right? So we can see this also gives finite value. It will give finite value. You can check it. Okay, so that implies this implies psi is wave function. Psi is wave function. Okay, so because it is satisfying all the 6 conditions, because value of x square is going to be positive always. Okay, so that's why psi equal to 0 at x equal to plus minus infinity. Okay, this is continuous differentiable and this square integrable as well, and this value is giving a finite value. Okay, well, this is the one. Let me just check it now. Okay, so 2-3 questions we are going to solve one more. Okay, for here I can solve it for you. This, if you solve it, so this is going to give minus infinity to plus infinity, and this is, will put the value, so it is going to give mod a square, will take outside, and the differentiation minus alpha x square. Okay, so and dx, this value is going to give mod a square, and this value by property we know, right? Is minus infinity plus infinity minus a x square. Okay, minus e to the power minus alpha x square. This value is always, you know, pi by alpha. Okay, so pi by is minus infinity plus infinity, so this is e to the power 2 alpha. Let me just check. Question is alpha square. Okay, so this is going to be pi by alpha, and limit will break the limit because it's a even function, so we make it 0 to 1, so 1 by 2 will come. Okay, this is the 1. Sorry, 1 by 2, now this 2 will come because we are taking limit like this 2. Okay, so you can see that this is giving finite value. Okay, very easy integration. It is square integrable as well, and this value psi value of psi is 0, and psi is also is continuous and differentiable. Okay, so that's why this function is wave function. Next, I'll just draw the graph, and like this question you can see, suppose we have like this graph. Okay, this one or this one, right? This may be the possible wave function. Okay, because this is continuous. Okay, and but if we talk about this graph we have been given like this is not the wave function, because we can see here clearly it is discontinuous. This may be possible wave function I'm talking. Okay, possible wave function. If we have given just this graph, possible wave function. Okay, and yes, this is the one. Well, this is about the wave function, right? So you can solve questions related to wave function and check whether whether function is wave function or not. Okay, and there is one more question which I'm going to solve right now. Okay, question number 6. This is the component of initial state the of component of initial state psi I. Okay, r component of initial state psi I r, we have been given phi 1 psi I initial. Okay, this is I by 3. Okay, and phi 2 psi I is root 2 upon 3. Okay, and phi 3 psi I, this is the component of initial state psi I. Okay, psi I, which is given 0. Okay, the component of final state are also given. The component of final state psi f are phi 1 psi f. Okay, this is given 1 plus I root 3. Okay, psi f is given 1 upon root 6, and phi 3 psi f is given 1 upon root 6. Okay, this is given. Okay, so now find the probability of finding the system in the state psi f. Okay, we need to find probability of finding particle probability of finding particle in the state psi f. Okay, you need to find out. Okay, so this is the question. The component of initial state psi I are given, phi 1 psi I, phi 2 psi, phi 3. Okay, and the component of final state psi f are also given. So you need to find the probability of finding particle in the state psi f you need to find out. Okay, very good question. We are going to solve it. So we know the probability of finding particle in the state psi is going to be psi f psi I. Okay, this mod square. Okay, so we need psi f and psi f and psi I we need to find out. Okay, so we have been given these conditions, right? So we have, so how to find this psi f? First of all, we'll find psi f psi I. Okay, get psi I. How we are going to find out? Psi 1 phi 1 plus, sorry, c1 phi 1 c2 phi 2 plus c3 phi 3. Okay, this is one. And now we need to find, so this is the psi 1, guys. And psi 1, for finding c1, how to find c1? So c1 is phi I psi I, phi 1 psi I. Okay, and this value is given, that is I upon root 3, which is given here, right? This is I upon root 3. And now we'll find c2. c2 means phi 2 psi I. Okay, and this value is given root 2 upon 3, root 2 upon 3. Root 2 upon 3. And similarly, c3 is given phi 3 psi I, phi 3 psi I. Okay, and this is going to be phi 3 psi I is going to be 0, which is given. Okay, similarly, we'll find, so we can write psi I now, psi I, putting this c1 c2 value. Okay, here in equation 1, value of psi I, right? We'll put it. So it is going to be 1 upon root 3, sorry, I upon root 3 phi 1 plus root 2 upon 3 phi 2 plus 0, because c3 value is 0, right? And similarly, now we'll find out psi f, that means psi final. Okay, this is going to be c1 phi 1 plus c2 phi 2 plus c3 phi 3, right? For psi f, we have been given this one. c1 is this, c2 is this, and c3 is this, for this. Okay, so we'll write it directly. So it is going to be 1 plus iota upon root 3 phi 1 plus 1 upon root 6 phi 2 plus 1 upon root 6 phi 3. Okay, now we'll find psi f. This is cat psi f, right? Now we'll find bra psi f. This is psi f. This is going to be 1 minus iota root 3, this one, phi 1 phi 1 plus 1 upon root 6 phi 2, it will remain as it is, plus 1 upon root 6 phi 3. Okay, is the one that there is mistake. It is going to be like this. Right, Batra sign. So now we'll find the probability. Okay, so this is going to be probability, right? Psi f, psi I. Okay, first we'll find this one. So this is going to be, I'll write directly. So this is going to be, will operate this with this, right? So we'll directly operate it. So this is going to be 1 plus iota root 3 into iota upon 3 root 3 phi 1 phi 2. Okay, sorry, phi 1 phi 1 phi 1 phi 1 plus 1 upon root 6 root 2 3 root 2 upon 3 into 1 upon root 6, and this is going to be phi 2 phi 2. Okay, 1 upon root 3 will come first, and then root 2 upon 3, and phi 3 is going to be 0 because value of phi 3 is 0. Okay, well, now this value is going to be, we'll solve it, so going to be I by 3 plus 1 upon 3 plus 1 upon 3. Okay, so we'll solve it. This is going to be 2 by 3 plus iota upon 3. Okay, now we'll find probability. Probability is going to be psi f psi I mod square, right? This is the probability, and right, and so this is going to be mod of 2 by 3 plus iota root 3 mod square, and after solving this we are going to get 1 upon 4, sorry, 4 upon 9, 4 upon 9. This is iota upon 3, right? Yeah. Iota upon 3, iota upon 3. Okay, and this is going to give 5 9. This is the answer, probability of finding particle, okay, in the state CSIR. Well guys, I'm going to stop here, and thank you so much for watching my lecture, and I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my lectures, which are absolutely free of charges, which is going to help you to crack the examinations related to physical science. Okay, thank you so much guys. Bye now.